it might fade out of range, or it probably will for like a minute, but it's not a big deal. I don't think y'all will say anything funky.
Not
So
relevant to the discussion at all. But Tacos, what dogs do you have? Just quickly, I'm a dog man myself.
I don't want to give that away, but they're nice dogs.
good dog.
I've got
So
beagles.
DeFreak, I accept metaphysics as the branch of philosophy that deals with abstract concepts. What do you think metaphysics is?
Sorry, I was on mute. Anything that's not physically measured.
What?
Whatever you can't physically measure.
Whatever you can't physically measure. What things exist that you cannot physically measure?
Stuff like, let's just say, like a twin's intuition, or
I can
phantom
measure
pains,
I
or
can measure pain.
other things that would be more in the spirit realm type of category.
Demonstrate spirit. You think metaphysical equals spirit?
I think it's something that is not measurable in the physical realm.
Demonstrate something that exists that is not measurable.
Twins intuition, phantom
Intuition
pain.
is measurable. Pain is measurable.
How is intuition measurable?
So there is a particular part of the brain that deals with intuition. It's kind of like a predictive thing. And we can scan your brain and show that this particular part of the brain exists, and it deals with intuition.
Yeah, I'm not buying it, Donald.
I don't care if you buy it or not. So can you show me something
I don't.
other than that? Can you show me something
Okay,
other than intuition?
so
Can you show me?
intuition.
Hello,
Hello.
hello.
Of
I'm in
what's
the middle of a
happening
conversation.
from one
I'm
state
in
to
the middle of a
another
sentence here.
there's a
I'm in
little
the middle
tingle
of a
in the brain
sentence.
somewhere, and that's a
I'm in
measurable
the
thing.
middle of a sentence. Can you demonstrate something non-physical other than intuition?
I have to think about it.
Yeah, go ahead. Think about it.
So, what do you think? What do you think about the notion that every time that you say, deleting babies and raping babies or whatever, every time you are asserting that, you're actually asserting that God is true?
Yeah, because God endorses baby raping and shit.
Okay, so if that's true, then how can you say that he doesn't exist?
Well, because it's a fictional book.
So then it's not true.
Of course, it's
Yo, next person to talk about baby stuff is getting kicked from the stage.
Got it. So the laws existed, but that doesn't mean that the God gave the laws. You have to demonstrate that God exists to give the laws, but before the laws are from God, whether or not they're horrible, which they are.
All right. The first 4 commandments are what?
Love God. There is no God above me. These things. Yeah.
Right.
False idols.
Yeah. Don't make
so
any
I guess that law was not given by God, according to you.
No, it was written down by people. People wrote it down. No God involved. Demonstrate that God exists.
Yeah, we can demonstrate
that God exists.
Yeah.
All right.
That.
You just said that random quantum fields can make predictions that and God can't.
No,
right?
I never said that.
About 10 minutes ago or 5 minutes ago.
No. I said that people can make prediction based on random quantum fluctuations of quantum field.
Wait, can you repeat that? You said, you said what?
People can make predictions based on the fluctuations of quantum fields, even if they're random.
I'm having a hard time grasping that concept.
I couldn't care less. I understand it very well.
Well, you can quantum field theory. We can use as a tool to allow us to make predictions about the universe that we live in.
Very
But the
accurate
quantum field
prediction.
on its own doesn't necessarily make the prediction. We make the prediction
Yeah,
using
we make
quantum
the
field theory as
predictions.
a tool. Yeah.
The quantum field exists, but we make the predictions based on the quantum field existing.
Yeah. If the quantum field is a ruler, then we use the ruler to measure your height. The ruler doesn't measure your height.
So,
Sure.
in a sense, we are kind of manifesting reality through the quantum field.
No, we observe reality happening and we describe it with quantum field.
All right.
So it's an observation. These things are based in observation.
All right.
This
And
is
so
this is the same disagreement I was having with Eli earlier, where it was a transcendental argument, where he was talking about the constants of the universe, like the laws of logic.
Oh, I have a chart. I have a chart that refutes fine tuning. There is no fine tuning.
But the quantum field
can
theory
we measure a quantum field?
Yeah, we can measure a quantum field.
All right. How do we do that? And where's one been observed?
With giga electron volts. That's the unit of measure, and we do it in particle colliders.
Okay, if it's in a particle collider, that means that the existence of that field could be less than a nanomillisecond, microsecond. Right?
No. Our ability to detect the particles produced by the quantum field lasts for that long, but the quantum field exists outside of space-time.
We're creating an environment that allows us to detect it, and the period of time that we can create the environment that allows us to detect it is
Produce.
very,
Don't say
very
create.
short.
Never say create with these people. Say produce.
Yeah, fine. But my point is that we're producing an environment that allows us to measure the field, and the environment that we've produced that allows us to measure the field, because it's such unbelievably high energy, we can only maintain for very, very, very short periods of time.
Giga electron volts we're talking about here.
Yeah.
So basically, it's an electrical reading. It's a voltage reading.
No, it's not.
Then how's it measured? And
how's it measured?
I don't know. I'm trying to figure it out.
Like electron volts. Yeah, we measure it, but you cannot measure something that does not exist, right?
Okay, so if it's outside of space-time and you needed evidence of something that is...
I didn't say that. I said it's independent from space-time. So it exists both inside of our space-time and outside of our space-time.
And this is not metaphysical?
No, it's very, very physical.
Yeah, it helps us explain, or at least begin to start trying to explain some of the phenomenon that we've been seeing for decades. Things like electron tunneling, for example.
Yeah.
All right. Would these be considered stable phenomenon?
Yeah, phenomenon are stable. So a phenomenon is a thing that exists in objective reality, right?
Well, if phenomenon is the wording that we're going with, how about I'll just say the event that was produced.
So no, you're saying no.
Okay, so that a quantum field is measurable for
it's a
very short amount of time. It's produced and it's not stable.
No, just because we don't always measure it doesn't mean it doesn't always exist. That doesn't make sense. It always exists. There are times when we can measure it, yes. Just because we can't measure it doesn't mean it doesn't exist.
So let's just say, like sci-fi movies or whatever, sometimes they have like time portals or whatever. And so would you say it's something like walking through that the portal is like the energy is something like the quantum field?
I would not compare it to sci-fi at all. I would never ever use sci-fi to compare it to reality ever. No.
Well, I'm just trying to, imagine kind of the energy or kind of the way it would manifest.
No. I'm answering your question with no. I would not do that. Because
All
that
right,
does
so then
not.
you're going to have to explain it to me then.
Okay, what do you want me to explain?
So this quantum field, which is in flux and not stable, and we produce it,
No,
and we can make
there's
predictions
nothing
off of it.
unstable. What? Why do you think it's unstable? There's nothing unstable about a quantum field. A quantum field is the most stable thing in the universe. It does not decay. Quantum fields cannot decay. So
But
it's the most.
it's in constant flux, right? Because a particle can be in
No,
two
it's
different
not in
places at the same time.
flux. What does that mean?
What?
Define flux.
A particle can be in two places at one time.
Oh, well, fields are not particles, so no, that doesn't apply. So the answer is no.
But fields contain particles.
No. Particles are excitations of fields. Fields don't contain particles. That doesn't make sense.
Okay, so then how could a quantum field manifest particles like the Earth or the universe?
Excitations. So an excitation of a field is a field that has energy. Energy directly from energy. If a field has energy, it can produce.
You're muffled.
Donald, you're underwater.
Yeah.
Yeah, not that.
Muffled.
So if a field exists, we can demonstrate fields to exist. Fields produce particles. They don't contain.
So
I'm not hearing him.
yeah, you're really muted. But from if I'm hearing him correctly, and obviously my rudimentary understanding of the physics, so like the colloquially they call them vibrations, which is excitation.
No, they don't. Excitations.
Yeah, excitations. But I'm sure like people have heard them referred to as vibration, not wanting to.
No, that's not a thing in physics.
I know it's not a thing in physics, but that's what people who
But we're
aren't
talking about physics.
illiterate call
Is
them.
there a difference between vibrations and frequency?
Yes. Vibrations are a thing that people feel. Like frequencies are a thing that exists in objective reality. We can measure frequencies. We cannot measure vibrations. I don't know what a vibration means.
So in a particle collider, when the actual particles collide, it exposes the quantum field that's always all around us and everywhere.
No,
Is that kind of what you're saying?
No, it excites it.
It excites it.
Yeah, it excites the fields that are always around us. That part you got right.
Okay, so it makes it kind of like, I don't want to say like visual, like, with the naked eye, but maybe that is the case, but it makes it known or manifest it into something that we can measure in the physical realm, right?
Not manifest. It was always there. Manifest seems like it was never there, and then we started.
Yeah, I understand.
Yeah.
So it exposes.
So, it's always there.
Maybe.
We in particle colliders, we excite the fields so that we can detect particles coming from them.
Yeah, that makes sense.
Yeah.
So the quantum
but we
field
have to
is
put energy into it to get that to happen.
Vast amounts of energy.
Yeah, lots, like 99.999% the speed of light.
Yeah.
So would you say that this is like a dimensional phenomenon, like a fourth dimension, a fifth dimension, a sixth, seventh, whatever?
You don't know what a dimension is. So a dimension is like length, width, depth, and time. Those are dimensions. There's not extra dimensions. There might be like multiple branches of our quantum wave function, but that would be like on a quantum scale. That doesn't.
All right. So is it exposing or showing us different planes of existence?
No, that doesn't make sense. What's a plane of existence?
Just maybe this whole plane that we're in right now, this Earth realm, is a frequency of like 1 hertz, right? Maybe a different one is at 2 hertz, and they're parallel to each other, right? Like just as a quick example.
Define plane of existence, please.
let's just say that this whole reality that we're all in this world, this
This is
globe
an
world,
example. I need a definition of plane of existence, please.
the reality that we're in,
Okay,
a reality.
that doesn't make sense. So, reality that we inhabit is more than a plane, right?
I don't know.
I do. A plane is 3 points on a grid.
Do you think that there's only one plane of existence throughout the universe?
I don't know what a plane of existence is.
It would be the universe. Let's just say the
Okay,
physical,
so
measurable,
no,
visual universe is the plane.
Okay, there's not more than one universe. The universe is everything that exists. So no, there's not multiple planes of the universe. There's a single plane of the universe by the way that you're defining it.
Yeah, I mean,
Couldn't it be argued that we have a wide spectrum of visible light and not visible light in the in the light spectrum, that every spectrum of light is a plane?
No, you can't do that because photons are orthogenic. They have a field that is orthogonal to another field. They're not one thing. So they're not a plane.
Also, since you can see multiple light frequencies at the same time, although not all of them, mean that you're experiencing multiple planes of existence at the same time. When
I don't even know what a plane of existence is.
Yeah, but if each frequency of light is a different plane of existence, then according to DeFreak, we live on multiple planes of existence at the same
It'd be
time.
billions. There'd be billions of planes of existence.
Yeah.
So is there one plane of existence or billions of planes of existence?
Well, the thing is, maybe there's a whole subset of beings that live in that, like, just say infrared light that we are not aware of.
What do you mean by beings?
Whatever exists.
Okay, so
I'm just hypotheticalizing right now.
So yes, there are billions of beings because there are billions of particles that exist.
But no, I think I get what DeFreak is trying to get. Like, is it possible that there are fields that we can't see into, and therefore, even if we can't see into a particular field of light, that doesn't change the physical interactions. So, for example, I can't see very far into the infrared spectrum. I can with my thermal and infrared optics on my rifles, but I can't see into it with my naked eye. But like, infrared light still bounces off physical objects even if I can't see it. So like, how is this?
Okay, well, let me try a different approach. Let's just say that the particle collider is a hammer, okay? And when the particles collide, we're hammering into some sort of like breach. We're breaching into something that could open up a whole other realm of reality.
That doesn't make sense. We're just
but you're saying that it's exposing a quantum field.
Stop. We're just exciting the things that already exist. We're not making anything.
Okay, but wait. If we're hammering into it, maybe we can eventually hold on a second. Hold on.
Doesn't make sense. I already told you that.
Hold on a second, Donald. Just hold on a second. I'm theorizing something.
It doesn't make sense. What you're saying doesn't make sense.
You haven't even heard it yet.
I have.
You haven't even heard it yet.
Into it doesn't make sense.
Relax for a second.
Don't tell me to fucking relax.
You're Donald, you said that it can. Donald, you said that it exposes somehow the quantum field that we can measure.
I never said that. Lying liar who lies, piece of shit, fuckface.
Well, whatever you said, it said that it makes it measurable to us.
I said that, you lying piece of shit.
What did you say then, Donald?
I said that we excite what's already there.
Okay, so we're able to see it at that point, right? Or measure it.
We can measure it without the Large Hadron Collider. We don't have to have the Large Hadron Collider to measure these things. We can measure these things just, in your backyard. But we excite the giga electron volt fields that are higher than the energy levels that we're used to experiencing, baryons, and we can excite leptons and higher than that. But these things don't just not exist until we excite them. They always exist.
Okay. But if the particle collider is hammering into the fabric of that,
no,
somehow
that's
we
not
can...
what it's doing. That doesn't make sense. It's not hammering into anything. What do you mean by hammering into something?
It's exciting it to the point that we can actually, I guess, according to you, we can, it gets excited enough to actually see or measure those particles that you were talking about.
We can always.
Okay,
do
so
that.
if we can constantly hammer away at it and make a breach in it,
Dude,
we can look inside of it.
Stop. You are wrong. So no, we're not hammering into these things. We can always detect these fields. Always.
That's not the point, Donald.
Shut up. I'm almost done. Shut up. We can always detect these things. We're just doing.
And Dave says a white unicorn with he did a super sticker. Thank you so much for the super sticker, Dave. Greatly appreciated.
We can always measure these things. We're just doing it in a laboratory setting. In the Large Hadron Collider, we're just doing it in a lab setting where we can measure everything definitively. That's all we're doing.
So do you think that the quantum field is the brick wall foundation of all of existence?
I don't know what that means. I understand that, yes, quantum fields exist. I don't know what you mean by foundational brick thing. I don't know what that means.
Are you asking if it's a ground state? Like it's the most basic possible state of the universe?
It doesn't make sense.
Well, I know it doesn't, but I'm trying to clarify what he's asking.
In other words, there's nothing beyond that. We can't drill into it and find something else, right?
No, quantum fields are the foundation of everything, yes.
Okay, so there's no point of hammering into it in order to access other realities.
I don't know what you mean by hammering into. We investigate quantum fields every day, 1 billion times a second at the Large Hadron Collider. We investigate the quantum fields all the time. I don't know what you mean by hammering into, though. That doesn't make sense. Yeah, but yes, we investigate the quantum fields constantly.
How?
Thank you very much for the super sticker, Dave Gar. Greatly appreciate it again. Sorry about that, guys.
At particle colliders, we do it with physics in general. We send things to Mars. That's an investigation of physics.
Asking what's underneath, like the quantum fields, is like asking what's underneath the foundation of your house, and then you go, what's underneath that? 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 And eventually,
right. That's what I was asking him if that was the foundation.
Yeah, shut up. Because let him finish. Shut up.
But it did like asking what's underneath the quantum field. It's like asking what's underneath that after you've dug your foundation so deep you've dug a hole all the way through the planet. There's nothing underneath.
Right.
We understand physics and we understand what quantum fields are. I've been explaining quantum fields to you all night. We very, very specifically understand quantum fields to degrees of certainty that you cannot comprehend. Sigma 5 is 0.00000% certainty.
Yeah, it's for all intents and purposes a statistical certainty.
You cannot get low. You cannot get more certain than what quantum fields suggest.
Right, I've got to go, guys. I've got to go and take my kids swimming and stuff.
Well, have a good one, John.
Just quickly to Donald. Despite our disagreement, which did get quite heated, I have enjoyed the conversation. I still don't agree with you on that particular issue, but I have enjoyed the conversation. So thank you.
You are wrong.
But we can agree to disagree, can't we?
I agree that you're wrong.
I agree that I disagree that you're wrong. But we'll see you later. See you guys.
All right, man. I can demonstrate everything that I say. I don't.
Okay, so Donald,
things that are wrong.
You say, sorry, you say that the quantum field can help us predict things. Predict something for me.
So I can predict the charge of electrons.
All right. Can you demonstrate it?
Yeah, we can measure electrons, and I can predict what they're going to be.
Do you have an example?
Yes, I just told you. Yes, we can measure. Do you think that we cannot measure electrons?
So measuring electrons proves a quantum field which can predict stuff.
No, predicting the charge of electrons is a result of quantum field theory. You have it all backward. I can predict electrons because of quantum field theory.
And what practical predictions or what practical use or practical knowledge does that, how does that manifest in our world? Like, to the common person out here?
Transistors.
All right.
So
and
your computer, your phone, every electrical device ever conceived or produced by man requires quantum field theory.
So alternative current electricity is quantum based.
Transistors, the electrical devices that you're not listening to me. Transistors. You cannot make a transistor without understanding quantum physics. You cannot make a computer with transistors without understanding quantum physics.
What's the difference between quantum physics and a quantum field?
Quantum physics describes the field. The field actually exists. Quantum physics does not exist.
All right. So everything electronic basically is based in quantum field physics.
Field theory, quantum field theory, yeah.
Okay. And okay. So let me think now.
Sure. I get that a lot.
How is that theory predicting things in the future for us?
Transistors.
I mean, besides being besides it reproducing its own measurement or whatever, right? I'm talking about like let's just say world events or
every phone made in the last 30 years. Everything that possesses a transistor. Everything that possesses a transistor conforms to quantum field theory.
But we had transistors way before quantum field theory was ever a thing.
No, we didn't. When were transistors invented? In the 1950s. When was quantum field theory invented? 1915.
Okay. Yeah, I think you're right.
We didn't have transistors before quantum field theory. We had to figure out quantum field theory before we got transistors because you need quantum field theory to make transistors.
So would you say like the quantum field is like the endpoint of like the endpoint of our reality, the grounding of the reality?
I don't think that reality has an endpoint. The fundamental thing of reality is quantum fields, if that's what you're asking.
Okay, so is it possible that there's more than does that mean that there's only one quantum field?
No, there's many quantum fields.
And could each quantum field produce its own quantum reality?
There's no such thing as quantum reality.
Could it produce its own quantum plane of existence. Like we're in a quantum plane of existence.
A quantum plane of existence. It doesn't.
Does our reality consist of more than one quantum field?
Yes.
Okay, so how do we know which quantum field is responsible for the foundation of the Earth?
None of them are. That doesn't make sense. The foundation of the Earth is based on gravity. Gravity is a property of the curvature of spacetime. Spacetime is produced by the quantum fields. Curvature of spacetime is mass bending spacetime, warping spacetime. So the planet is based on the warping of spacetime.
How big are quantum fields?
Universal. They're everywhere.
When you turn on your computer, does it create a quantum field?
No, the quantum field was already there, but yes, it uses the quantum field.
Is it the same quantum field every time, or is it just a kind of a new one that gets fired up with the electricity that is fed to it?
So the quantum fields that it affects, it will only affect those quantum fields always. It will never affect any other. It will hang on. It will never affect any other quantum field. Like a wire cannot affect the nucleus of an atom. They're different.
Okay,
fields.
so sorry, go ahead.
They're different fields. That's all I said.
So quantum fields kind of have a cell wall?
I wouldn't say that, no. So quantum fields are a thing that exists everywhere, but the excitations, like quarks, in the 3 quarks make a proton, and it involves neutrons and neutrinos and stuff.
And so all these particles are kind of free roaming and free floating, and they can use off. They can piggyback off each other. They can exchange off of each other.
No. So the electromagnetic field will interact with the weak nuclear field, but the weak nuclear field will never interact with the strong nuclear field, and the strong nuclear field only interacts with gravity with mass. So you don't know what you're talking about.
Well, it just seems a little, vague and a little inconsistent.
It's not vague at all. Physics describes this stuff very, very specifically. It's not vague at all. If you understood the physics in any way, you would never have said those words. And you should never repeat those words ever again. You sound silly.
Have you ever heard that those words before, or that,
No, I've never heard those words before. You are the first person to ever say those words to me, and you should never, ever repeat them to anybody ever. They're stupid.
So the quantum fields are everywhere. They don't particularly necessarily interact with each other or collapse into each other. Yet they do exchange particles with each other, and the particles within them can be in 2 different places at the same time.
Stop. What you're saying doesn't make sense. I don't know what
it doesn't make sense.
I don't know what collapsing fields into each other means. What does that mean?
Well, you said that the quantum fields that are all around us everywhere, they don't, they remain separate from each other. Like they're their own field, right?
I said they do interact with each other. I didn't say they said. You're saying the opposite of what I said. You're lying.
Well, that's not that. Okay, but they are independent of each other, and they remain. Their structure remain. They don't get breached and collapse into each other.
I don't know what that means. What does it mean to breach or collapse each other?
It means that they remain. They remain like they, are stable fields all their own.
Persist.
Okay, so how do they exchange energy between each other?
Photons.
Okay, so let's just say you have a the soap bubble kind of example that's used sometimes for string theory, right?
No,
those
I don't care about
bubbles
string
are
theory.
defined.
We're not going to talk. We're not going to talk about string theory because it's
I'm
garbage.
just using the soap bubble as
no,
an example.
I'm not going to accept anything that is based on string theory ever. Period.
Could you say that soap bubbles could represent each quantum
I
field?
cannot accept anything based on string theory.
Forget about string theory. Could a bar of soap with bubbles on it, the bubbles represent some quantum fields?
No.
As separate things?
No.
How do these quantum fields exist with each other? Like, what shape do they take?
They don't have a shape. That doesn't make sense.
How do they maintain their structure and integrity?
Well, they have a structure. They don't have a shape. They have integrity. They don't have a maintaining integrity. That doesn't make sense. But
are there different variations of quantum fields and they all have different functions?
No. There are different quantum fields.
Okay, and so let's just say one quantum field has something that another quantum field has, and that quantum field has something that that quantum field has, and they exchange energy. They still remain distinct from each other, right? But separate but equal, or something like that.
No, not equal. That doesn't make sense. So yes, quantum fields are distinct from each other. They exchange energy through photons. I've explained this already.
Is a photon a quantum field?
Yes, a photon is the force-carrying particle for the electromagnetic field.
Is every subatomic particle a quantum field?
Yes, every particle is a quantum field. It's an excitation of a quantum field.
Okay. All right. Now I think I'm starting to get it.
It's complex. I get it. It's hard to understand. It took me 35 years.
Do you think that there's anything when we collide particles in the particle collider? Do you think there's anything beyond what comes out of there? Like, are we going to be able to find anything to actually peer into and put under a microscope?
I don't know what that means, but yes, there's certainly things that we can't excite. There are certainly quantum fields that we cannot excite with a Large Hadron Collider. Of course there are. The Large Hadron Collider works in a very specific range. It works within proton-proton interactions. These are quarks, so it's going to be baryons. Anything outside of baryons, we're not going to be able to investigate with the Large Hadron Collider. There's more things that exist besides baryons.
Okay, so based on that, if we're able to hammer into that to the point of, I don't know what that means. It means that you're constantly colliding particles to create or to try to breach through a different phase of the quantum field.
We're doing a billion experiments a second at the Large Hadron Collider. A billion experiments a second. 24 hours a day.
Sure. So let's just say that we were able to make a breach in the reality that that colliding particles would cause. Okay.
What does breach reality mean?
It means that you're able to somehow cause a breach or a phasing of matter by colliding the particles. And if we could peer into that, would there be a different dimension on the other side?
No, you don't know what dimensions mean. So dimension is like height, length, depth, and time.
Okay, would there be another plane?
Hang on. Can I answer your question? These are dimensions that we understand exist. There is no other dimension in our universe that we understand to exist besides height, depth, width, and time.
But couldn't we hammer into a different plane of existence?
I don't know what a plane of existence is. Define plane of existence.
A plane of existence would be something that is able to exist on a different, let's just say a different frequency than we're on.
Oh, and there's a very hang on. There's a very valid question from Doombase, yes. What does this have to do with Jesus resurrecting? Thank you, Doombase.
Nothing. But I don't know what you mean by plane of existence, so I don't know what that means. You're going to have to explain what a plane of existence is, because I don't know what it means.
You just said that there's got to be something more than the barium that's produced in particle collisions, right?
Leptons and bosons.
So let's just say beyond that, we're able to peer into a different plane of reality. Like maybe it's a means of time travel.
What do you mean by peer?
Actually look and observe something else.
Okay, into a different reality. What does that mean?
Something like, either a wormhole type scenario or a whole nother different plane of existence produced by a quantum field.
Wormholes are not a different dimension. Wormholes are our dimension. Wormholes are entanglement. So two particles that are entangled by wormholes. Wormholes are not a different dimension. They're the same dimension. They're just a shortcut involving less space-time.
Have you heard of anti-gravity and antimatter? Are those different?
Thing that exists. Actually, we've performed experiments at the Large Hadron Collider that show that antimatter interacts with gravity exactly the same way as matter does, which is very cool.
But this is still in the same plane or the same realm that we're in now, right?
I don't know what that means. What is a realm?
It means we're in this. We can interact with it on our level, right?
Okay, we can interact with lots of things that are not on our level. We can interact with bosons that are not leptons and are not baryons. I don't know what you mean.
Have you never heard the tearing into the fabric of the reality? You've never heard of something like that?
What is it? What does it mean?
It means tearing through the particle plane to see what else is out there or whatever.
You're using the word you're defining in the definition. So it's just a useless tautology. Until you
if that's the case,
tautology, I don't know what you're talking about.
Okay, so if what you're standing on is the case, that means that the quantum fields are not able to produce anything than this physical reality that we can interact with. Would that be a correct statement?
No, we can't interact with all quantum fields, so no.
So then tearing into the fabric of reality is a possibility.
I don't know what
we can see those other quantum fields.
The fabric of reality. What is the fabric?
The quantum field.
No, it's not a fabric. I don't know what you're talking about. I don't know what you mean to tear into. What does tear into mean?
It means cracking through by colliding the particles.
There's none of that. That doesn't even make sense. You can't crack through something that exists. It doesn't matter. It doesn't make sense.
So you said that we can't see or we can't whatever all the different quantum fields. But if we do, okay, if we are able to somehow eventually interact with those quantum fields, they still will be part of this. They'll still be part of this reality, right?
Yes, they exist, but we cannot interact with them.
Okay, so would it be fair to say that they're in their own reality?
No, they're in our reality. We just can't interact with them.
Okay, so if we can't interact with them, we can't really know about them. Could they have a whole
This is important.
Existence?
This is important.
That have aliens or
something.
This
is important. This is an important thing. They're just too high energy. We don't have the capability of producing the energy required to interact with them. If we could, We would be able to interact with them, but we just can't do it right now.
Okay, so let's just say that there are other intelligent beings out there that can. Is that a possibility?
Okay. Sure.
Okay, there's your evidence for metaphysical.
Define metaphysical.
Something you can't measure physically.
Well, then I don't agree with that definition, because metaphysical just means that it is a branch of philosophy that deals with abstract concepts. So your definition of metaphysical is nonsense.
Okay, so any abstraction thought that is not physically able to be measured is metaphysical to you, like intuition or phantom pains.
Stop. Abstract thoughts are physical.
So when let's just say when there's enough heat, say in a like our sun is able to fuse particles to like make helium from hydrogen, for example. Okay, in that case, wouldn't you have to admit that those quantum fields are actually losing integrity to combine and become something else?
No, there's no decay of the fields that causes fusion. It's the opposite. It's constructive interference, not destructive interference. Yes, there is.
Right, but they're losing integrity,
Hang on,
though.
I'm almost done. Honest, I'm almost done. Yes, there is deconstructive interference, but that's not a thing that causes fusion. So I don't know what you're talking about.
Well, I'm just saying, because you're saying that the quantum fields they always maintain their integrity, but they can still pass on energy.
I've never ever said that. I don't know what that means.
Anyway.
So can you define what maintaining their integrity means, please? Because I've never said that.
Well, you said that they are particles and that they can interact with each other and exchange with each other, but yet they maintain their integrity.
I never said that. I said that particles.
You said something along those lines.
No,
I might be paraphrasing.
I'm going to tell you what I said. I said that particles are excitations of fields, and the photon is the force-carrying particle for the electromagnetic field. That's what I said. I never said anything that you said I said just now. Never ever said any of that.
I don't know, man. It just seems like a lot of voodoo physics out here.
There's no magic whatsoever. Magic doesn't exist. If you say voodoo magic bullshit, you're just making shit up. It has nothing to do with physics. There's no magic in physics. It's all very, very explained. That you say there's magic involved is just your misunderstanding of the physics. It's not the physics.
Well, it's just the inconsistency of the different concepts.
There's no inconsistency. What is the inconsistency?
From the particle collider to the integrity of each field to the
I never
stability of the fields.
Integrity of fields. I don't know what you mean by integrity of fields, so that's not what I'm saying. You're just making shit up.
But you say that they remain independent, or they don't get absorbed into each other. They
don't know what that means.
Exchange.
I don't know what any of that means. There's no such thing as absorption. What does that mean? I said that they interact. What quantum fields interact?
Okay, why do they interact?
What happens when they interact? Particles. Particles happen when they interact.
So, like chemistry.
Well, particles come before chemistry, but chemistry is based on physics.
Okay, so they exchange particles in order to form stable compounds and stuff like that, right? But yet those quantum fields, even though those particles stabilize and form compounds, the fields remain independent and remain their integrity.
Stop! No! That doesn't make sense what you're saying. Interactions happen, yes. What do you mean by the rest of the bullshit that you just said? Because you wouldn't
if there's an interaction,
you wouldn't stop talking long enough for me to ask you anything about what you just said. You just kept preaching. So what you're saying is nonsense. I'd like for you to explain what you mean. What do you think I mean when I say interaction? Explain that.
Some sort of exchange of energy.
Sort of. No. There can be an interaction without energy. So I don't know what you're talking about when you say things that make no sense. An interaction is just quantum fields that either constructively or deconstructively interfere. There doesn't have to be energy involved. Generally, there is, because energy is what makes quantum fields fluctuate. But that's very undefined in an expanding universe, which we live in an expanding universe. So energy is not well defined. So I don't know what you're talking about.
So
you have to say things that make sense.
When two different elements combine and make a different kind of molecular compound, it usually ends up being the most stable.
Oh shit, wrong one. Dave thinks we need a voice of reason here. He thinks there's no voice of reason between y'all.
Okay.
I mean, I understand what Donald's saying.
Very reasonable. This guy is nonsense, but I think I'm being very reasonable.
Anyway, so in chemistry, things will balance out to a stable compound in general, right? No matter what the reaction is.
They try. So elements want. So it's very anthropomorphic. So elements want to reach the lowest energy state possible. When they combine with other elements, atoms, covalent electrons dominate. They're going to decide what does combine and what does not combine to make stable atoms.
So is it fair to say that the quantum fields are the proton fields and the electrons are just free radicals that are trying to stabilize?
The opposite. Protons are made of quarks. Quarks are the quantum fields. Electrons are quantum fields. You're saying the opposite of fact.
Okay, so quarks electrons?
No, they're different fields.
Okay, and quarks, you said that 3 quarks make a proton, or did I hear that wrong?
Yes, 3 quarks make up a proton. Either up, up, down, or down, up, up, or down, down, up, rather. That's baryons. That's what we can interact with. There's other forms of quarks that we can't interact with.
Okay, so what is the stabilizing quantum field consisted of? What does it consist of?
I don't know what that means. The quantum fields don't sustain or have. I don't know what you're talking about.
What maintains the integrity of a proton?
There's no such thing as maintaining. I don't know what that means.
Okay, so if 3 quarks make a proton, and protons kind of make the base of a molecular compound.
No.
The electrons are the free floaters.
No. So protons are inside the nucleus. They do not interact with the electrons. I don't understand what you're saying. You don't make sense. What you're saying is gibberish.
How does the quantum fields interact with chemistry?
Electrons and photons.
So then how does that quantum field maintain its integrity?
I don't know what you mean by maintain and integrity. I don't know what those words mean. What do those words mean?
If the photons and electrons are interacting, combining, or ejecting or stabilizing within a compound, where's the quantum field in that equation?
None of that makes sense. Electrons are...
All right, guys. I really appreciate all of you hanging out, but it is bedtime for me. I am going to grab brunch and go to sleep. Or not really brunch. You know what I'm saying, like just lunch, breakfast, whatever. But you guys have a wonderful, wonderful, wonderful day. I'm going to play a couple songs real fast, and then
thank you, Taco.
I'll be back on this evening, so make sure y'all all drop back by again this evening, and I greatly appreciate you all. Let me see. I don't think I played God Has No Butt today, so we'll play that one, because that one is a banger.
God has no butt. God has no butt. Butts on boats. Butts on boats. Does God's butt float? God has no butt. Butts on boats. Butts on boats. God has no butt. Butts on boats. Butts on boats. Does God's butt float? Does God's butt have a moat? Do you need Dante to take you through on a moat? God has no butt. Butts on boats. Butts on boats. God has no butt. Butts on boats, butts on boats. Float. Take control. You have a butt. God has no butt. Take control. You have a butt. God has no butt. You are more powerful than God. You are more powerful than God. Because you have a butt, 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 butt. Does God's butt float? No. Does God's butt have a moat? No. Do you meet Dante to take you through on a moat? No, 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 no. Take control. Take control. Take control. You have a butt. God has no butt. God has no butt. Butts on boats. Butts on boats. God has no butt. God has no butt. Butts on boats. Butts on boats. Boats, 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 boats. Take control. Take control. You have a life. You have a life. If the sea is deep and the night is cold, who survives the crossing? The ones with boats, the ones with butts, the ones who float. has no but. God has no but some boats, but some boats. God has no but some boats, but some boats. Does God's butt float? Does God's butt have a moat? Do you meet Dante to take you through on a moat? Take control. You have a butt. God has no butt. You are more powerful than God. God has no butt. God has no butt. God has no butt. But some boats. But some boats. Say my name, say it clear. The freak is me, still here. Loud and clear, little weird, still here. Touchy strange, I don't care. Little weird, ain't no stairs. Say my name, say it twice. Feet top, stay like ice. Dial on, list the low, still right here. That ain't go. Say I'm odd, say I'm loud. Little weird, say it proud. Say it slow. Say my name, say it clear. The freak is me, still here. Loud and clear, little weird, still here.
everyone. I appreciate you all. You are all awesome. Thank you for being here and hanging out tonight. I hope you are this morning. You all have a wonderful morning. I will see you all soon. I'm going to go eat and go to sleep. I'll be back on in a bit. See you guys soon. Everybody have a wonderful day.